Okay, so we did examples 1 through 4 in the first video, and I had you stop there, but let's go ahead and finish up here for examples 5, 6, and 7. Okay, so we're putting everything together here. All right, so we've got 2 pi x plus 4 pi equals 0. Let's find the endpoints here. So we're going to have 2 pi x equals negative 4 pi. And so x equals, we divide there and get negative 2. And so also we have 2 pi x plus 4 pi equals 2 pi. And so let's go ahead and solve this. 2 pi x is going to equal negative 2 pi. Divide by 2 pi, and x is going to equal negative 1. So that's our start and our end. So this is all over here. So here's negative 1. And here's negative 2. And we need 3 tick marks in between them. Right? So this is going to be kind of a squished graph. We know that our amplitude is negative 3, so that means we're going to start flipped over. So this is a cosine. Normally we would start high, but we're going to start low this time. We're going to be flipped over down here. Okay? And then we would come up. Keep going up, come back, and finish low. So it's a skinny, kind of steep curve there. So that's the graph of negative 3 cos 2 pi x plus 4 pi. 51 is yours. Very similar. All right, let's take a look at 2 plus 3 cos 2x. Okay, so this is going to have a horizontal shift. And on this one, I'm sorry, a vertical shift, but no horizontal shift on this one. So let's take a look here. Cosine 2x, period is 2 pi divided by 2, which is pi. And no horizontal shift, so we'll start at 0. 1, 2, 3, 4 more. We'll end at pi. Midpoint is pi over 2. And we're going to have an amplitude of 3. 1, 2, 3. But that's going to be shifted up by 2. 2 more. All right? So this is cosine. Normally we would start high, so we would normally start at 3. We're shifted up more. We're here. Normally we would come back to 0, but that's shifted up by 2. Normally we would go down to negative 3, but that's shifted up by 2 to negative 1. And then let's come back up to finish the 5 important points. Connect your graph, and there you go. See if you can deal with a horizontal translation and a vertical translation on 57. All right, lastly, we've got this math modeling here, and so this is going to be a regression. We've done a lot of these in the past, and this time we're going to work on a sine regression. So let's go into stat, and in our list here, I'm going to clear this out. I'm going to make midnight 0, so 0 to 4 a.m., 6 a.m., 8 a.m., 10 a.m., and then noon is 12. Let's go clear out list 2. And our value is 3.4, 8.7, 11.3, 9.1, 3.8, 0.1, and 1.2. All right, so we're going to do a sine regression on this. So let's go into stat and do our regression. Now, before we've done a quad regression or a linear regression, if we keep going all the way down, we've got sine regression down there. Hit enter, and it comes up with these as our options. Okay, we can go ahead and plug this into our y1 and then solve for all the rest of the problems. You guys can do that. I'm not going to spend too much time doing that. What I really want to focus on is the fact that we can do a regression for a sine curve. This gets us all of our A, B, C, and D points for a sine curve. All right? So you would also be able to do something similar for 91 based on a real world problem. All right? So a lot of problems in the real world that have sine curves. Piano tuning, a lot of sound stuff involves wave motion, so we'll look at a couple of those. So take a look at 91, see how you do. All right, anything else than that, make sure you ask in class, and good luck with those problems.